In Pokemon Champions, if you recruited a Pelipper for your rain team, you might end up with a stat spread like this, with max special attack and max physical defense. And you might be tempted to just hop on the ranked ladder with it. After all, there's a lot of strong physical attackers in this metagame, like Sneasler and King Gambit. But if you have experience team building, this probably doesn't sit quite right with you. Pelipper's defense is already pretty good, so you would get more bang for your buck by investing in HP instead. However, if you put this into a damage calculator, you would find that this Pelipper spread has slightly more physical defense. So if I'm interested in optimizing the physical bulk of my Pelipper, how should I allocate my stats? That's the question that I want to answer with this video. How to optimize defensive spreads using math. To introduce myself, I'm Jenkins. I've been playing VGC for about 3 years, and I've achieved multiple regional day 2s, including an internationals day 2 and a regional top cut. And often I've used creative strategies with teams that I've built myself, including Wheezing Priority Spam in Regulation F, and Howl, Hisui, and Arcanine in Regulation H. This is a topic that I think is kind of mystifying for a lot of newer players. I'll be assuming that you have some familiarity with team building, at least at the level of understanding things like jump numbers and speed tiers. If not, I'll have some of Jamie Boyd's guides linked in the description. But when it comes to defensive spreads, there are often a lot of micro-level decisions that aren't necessarily intuitive. So I want to provide some mathematically grounded principles that can help guide your decision making and know that you are being efficient. So first off, when we are considering optimizing something, we are minimizing or maximizing a specific value. That could be our physical bulk, our special bulk, it could be our overall bulk. Maybe we care about one stat a little more than the other because of the particular role a Pokemon fills on our team, or because there's a particular metagame threat that we want to counter. And all of these pose slightly different problems that we would allocate our stats slightly different for. As our first example, let's consider our physically bulky Pelipper taking a common hit and an Aerodactyl Rock Slide. This graph shows, on the leftmost part, a max HP Pelipper ranging all the way to a max defense Pelipper, or a Pelipper with all 32 points invested in defense. And we can see that the Pelipper with all of the points invested in defense is slightly physically bulkier than the max HP one. But the true minimum lies somewhere in the middle, around like 48 HP, 41 defense. So how can we find this minimum in general? And for that we need to start with the damage formula. At level 50, damage is calculated as 22 times the attack power times our opponent's attack stat over our defense, all over 50, plus 2. We want to minimize the percentage of HP that we're taking, so minimizing this value over our HP. And this is done with a fixed amount of total stats. If we allocate a stat to our HP, then we're taking it away from our defense. And this is roughly proportional to 1 over HP times 1 over our defense. This is because those are the only two variables that depend on our stat allocation. Everything else is going to be held constant. And this is actually the same as a classic intro calculus problem, where you have a farmer with a fixed amount of fencing, say 100 feet, and he wants to construct a rectangular pen that maximizes the enclosed area. And this is done when the area is a square. That is when the length and width are equal to each other, or in our case, the HP and defense. There is a small caveat here that because there's this +2 in the damage calculation, we care about our HP just ever so slightly more, but as we reach larger and larger damage values, having our HP equals to our our defense is a better and better approximation. And as you can see in the case of Pelipper and Aerodactyl, the difference is pretty negligible, a fraction of a percent. Now, in singles battles, we only deal with one side of the physical special split at a time, typically. And that's why you have things like physical and special walls where this kind of optimization might apply. That's the foundation of classic cores like Skarmbliss. But in VGC, you're often going to be taking a physical hit and a special hit on the same turn, and you won't have the opportunity to switch out. This is why the best VGC defensive Pokemon are things like Incineroar and Amoonguss that have much more balanced stats. So you might think that since both defense and special defense matter, that HP would always be the way to go, since it affects both of those stats at the same time, outside of like some extreme outliers like Blissey, where the HP stat is so high that then only then you would care about investing in your stats. However, there is a common Pokemon in the Champions metagame where this is not the case, and that is Farigiraf. Now, Farigiraf's HP stat is good, but it's nothing crazy, only 120 base HP, and its defensive stats, aren't amazing, but again, nothing crazy low. But this is actually a case where investing only in our HP is inefficient. If we look at this graph here on the right, investing entirely in our HP corresponds to this back center peak, which actually looks pretty bad. The only worst cases are when we're entirely investing in either our defense or our special defense. And the true minimum occurs around 102 defense and 102 special defense, which puts our HP at 203. So, how do we find this minimum? And it's roughly the same problem, except here we can think about taking a physical hit and a special hit in sequence and adding the values together. Now we're minimizing 1 over our HP times 1 over our defense plus 1 over our special defense, again with a fixed number of total stat points. And because our defense and our special defense are equally valuable, obviously we would want them to be equal, and then our HP is equal to their sum, 2 times one of these individual stats. And this makes sense, right? Our HP would be roughly 2 times as valuable as either of our individual stats. In fact, we can also introduce a bias term that tells us how much we value our defense over our special defense. And the problem seems basically the same. Our HP is still equal to the sum of our defense and our special defense, but now we choose our stats so that the ratio of our defense to our special defense squared is equal to B. So if B was equal to 4, we care about our defense 4 times as much, we would want our defense stat to be twice our special defense. And here is an example of a bold Farigiraf spread that is the optimal set for taking physical hits about 2 times as hard as special hits. Now, I'm sure some of you are already writing your angry comments that this isn't really how damage calculation works. I'm treating this as if it is a continuous problem, when in actuality, it is a discrete problem. And in doing so, we have to introduce truncations and roundings to keep things integer valued. And this actually changes things significantly. Let's return to the example of Pelipper and Aerodactyl. This graph looks completely different than it did before. Now, our minimum is at 152, 137. Not only that, but the difference between our worst case and best case scenarios are much, much larger. Whereas before it was only about a point, now it's almost 3 points. So, what exactly is going on here? Well, first you'll notice that we have these ascending lines. This is because allocating an additional point to your defense doesn't necessarily decrease the amount of damage you're taking from a given hit. So when you allocate an additional stat there, you're just purely taking it away from your HP for no benefit. So we want to hit defensive stats that are the smallest that let us hit particular damage benchmarks. But there's something else going on here. We see that after each of these lines, there's a drop where the value of the damage changes. And some of these drops are larger than the others. And the smallest values align with the larger drops. So, how do we find these larger size drops so that we can allocate our stats to put us at those favorable points? I've heard folk wisdom before that you should have your defensive stats be odd to get favorable rounding and damage calculations. And this kind of makes sense. It aligns with things that we see in like choice specs or like life orb recoil. But, you know, and here we see like 127 and 137 showing up. Maybe that's true, but if you look closer, there's also some even numbers involved. So that doesn't seem quite right. This is because our defense stat and its properties don't actually matter that much. What really matters is our base damage. Here we can use the example that VGC players will be very familiar with, which is Surging Strikes in Rain. Now, Surging Strikes in Rain comes with a number of modifiers. Specifically, it is a weather boosted move, it is a critical hit, and it is a stab move. And so we can calculate what our base damage and final damage will be, ranging from 30 down to 20, which are pretty reasonable base damages for a move like this. We see that we start up at 100, then drop to 96, 94, and we get this pattern of jumps. 4, 2, 4, 3, 5, 1, 5, 3, 4, 2, and then it actually repeats. It continues on 4, 3, 5, 1, 5. And we would really like to choose our defense such that it puts our base damage right around those larger jumps, those 4s, those 5s. This is especially true for Surging Strikes because as a 3-hit move, these jumps are actually 3 times as large. And again, this is always talking about the maximum damage done. There is a random modifier that is introduced in damage calculation, but generally, you want to live hits even in the worst case scenario. So we'll be talking about maximum damage. So, what is causing this pattern of jumps? Well, damage is calculated in 2 steps, as we've covered. First, base damage is calculated, and then a series of modifiers are applied. Each modifier is applied to this sort of base damage or the running total of damage, and then rounded with half integers rounded down. And this rounding creates these jumps at regular intervals. A good example of this would be with a stab move. If your base damage drops from an even number down to an odd number, that 0.5 will get rounded down and create a jump of 2. Whereas when you move from an odd number to an even number, it only creates a jump of 1. And that creates this repeating pattern of drop by 2, drop by 1, drop by 2, drop by 1. But when many multipliers are added, the size of these jumps ends up compounding, depending on the exact properties of the next number in the chain. So, a few questions. What is the maximum size of these jumps, and how can we predict where they are? The maximum size for Surging Strikes, for example, is 5, as we saw. This is because at each step, we want our damage to round down, and thus the size of the gap to round up. So we start with the ceiling of 1.5, which gives us 2. Multiply that by 1.5 and take the ceiling, gets us 3. And then multiply by 1.5 and take the ceiling again, gives us 5. And the pattern of jumps that is created by these iterated multipliers is periodic, with the period determined by the denominators of the modifiers. Often this is the product of all of those denominators. There is some potential for cancellation that will complicate this a little bit, but generally that is the case. And in the case of Urshifu, it is period 8, 2 times 2 times 2. And this maximum value is always achieved. Again, there's a slight caveat for cancellations, at some subset of the remainders in this period. So I'll give you some examples of this in practice. So we have a little app here that allows us to select any number of post base damage modifiers. These are always applied in this exact order. Also, big shout out to Dawabafet for writing his damage dissertation, which has been an invaluable resource as I've been developing this. So with Surging Strikes and Rain, we have Weather, Critical Hit, and Stab. Our attacking stat is 200. Our base damage is 25. And our defensive minimum will be 75 and maximum 107. These corresponds to the defensive stats of a Flutter main. And this app then calculates what the maximum damage will be. As we said, it's 5. The period, which is 8. And what exactly the remainders mod 8 we want are, which in this case are 1 and 7. That is the 23 and 25 that we saw in the table. And it even calculates the defensive stats that put us in these favorable damage remainders. In this case, 75, 92, and 101. And I bet if you have made a Flutter main set in the past 3 years, you have used 101 as your defensive stat at some point. As another example, we could consider something like something with a lot of modifiers, like Pelipper Muddy Water against a Rhyperior with a Pasho Berry. In this case, this would be a spread move with the Weather Boost, with Stab, 4x type effectiveness, Solid Rock, and of course the Resist Berry. Our Pelipper has attack stat 161, the move power is 90, and the defensive stats are the same. And if we click calculate, we'll see that we can save a maximum of 5 points. The period is 32, and it occurs at these remainders, which correspond to these defensive stats. If you don't believe me, you can plug it into a damage calculator for yourself. So, the real question, though, is can we choose our defense stat so that we can consistently take advantage of this, so that our base damage is always landing in some kind of favorable set of remainders? Well, let's look at the base damage formula again. It's the same as it was in the continuous version, but with a couple of these floor functions introduced. If we consider this as a function of attack times move power, which we allow to vary freely, and we hold our defense fixed, then this is just an integer step function. And changing our defense just kind of stretches things out. The values that it hits are always just every single integer in order. So over a suitably large range of attack powers, say Meowstic Fake Out to Floette, Mega Floette Light of Ruin, the base damages are always going to be equally distributed over all of the remainders. In other words, if you want your base damage to be odd, at best, in general, it's only going to be odd half the time. If it needs to be a particular residue mod 8, it's only going to be that residue 1/8 of the time. So, therefore, there's no general advantage that you can get from having your defensive stat have some kind of property. Everything is in terms of a particular attack stat and move power. Now, it may turn out that there's some overlap in what the most powerful common moves in the metagame are, and that might make some numbers more desirable than others. if you want to see me do that analysis once we have some showdown EV data, then subscribe to the channel and I might just run that analysis. So this gives us a final framework. First, you try to make your stats sum to your HP. If that's not really possible with the spread that you have, you're going to want to invest in whatever your lowest stats are roughly, since that's going to give you the best marginal return, but generally that's the neighborhood that you're aiming for. And once you're around that point, you want to find those meta-relevant benchmarks where you can free up an additional point or two to either put back into your HP or maybe hit a more important benchmark in your other stat, or just hit important 2 or 3 hit KOs, survive the strongest hits. But something to keep in mind is that moves that have a lot of multipliers are going to have these large jumps. And that might mean that it's worth it to take a large number of points away from your HP to live these very strong hits. This also applies to multi-hit moves, right? Because if you have a 5-hit move, then reducing your maximum damage by 1 actually decreases it by 5. But as stated earlier, there's no general property there's no property of your defensive stats that is going to provide any kind of universal advantage in damage rounding. It's always dependent on exactly the stats and moves that your opponent is using. All of this probably isn't surprising if you've been team building for a while, but I hope it was at least interesting to see how kind of the underlying mechanisms work. If you liked the video, subscribe, share it with somebody you think might find it interesting, and drop down in the comments what your favorite defensive spread you've used is. If I had to pick one, I think it would be my max speed, max special defense, almost, Dragonite that I ran at NAIC and almost got me top cut. That one could live a Chi-Yu Heatwave into Beads of Ruin, Life Orb, Astral Barrage, and I got a lot of value out of it. So yeah, drop your favorite spread down in the comments. Peace.